Hello and welcome back. So, today we will start with lecture 3. In lecture 2, we have looked at a few theories of speech perception among infants, and most notably we looked at the motor theory and the universal theory. So, during our discussion on those two theories, the primary assumption, the primary theoretical position that we looked at was that human children are born with the capacity of categorical perception. Right. So, that understanding of how acoustic signals map onto phonetic codes is something of a innate feature among human children. That is what the idea was. So, motor theory had one position with respect to how we do that, universal theory on the other hand also has a same. So, both of these theories basically talked about how it is an innate feature, and probably we are born with some sort of a capacity to distinguish among sounds sound input that we get, and this is near universal in the sense that children are capable of making that distinction across native and non-native languages. However, there is also some amount of proof on the other hand that show that this is not exactly universal. So, not only we do not lose all the capacity for distinguishing between different sounds at a later age, but also sometimes even the sound contrasts that are native to the language of the child, that also is not always correctly figured out. So, there are this kind of contradictory findings, and because of which now we are now come to a situation where there are a few understanding that emerges. One, that human children are born with some innate capacity to have the understanding of differences between sound, maybe based on acoustic features, maybe based on the gestural features, or if you go by the motor theory, it can be also dependent on the articulatory feature, which is the perceptual at a perceptual level that categorical differentiation is possible. And we also talked about how the finding of mirror neuron has provided some sort of a support to this theory. Now, the idea that emerges from the contradictory findings is that probably during the first few months of life till the age of 1, let us say, children's ambient language also has a role to play in how they eventually are able to segment sounds, how they are able to distinguish between the phonetic and phonological contrasts. So, the idea that is how the idea started, and the theoretical position that is based on this basic idea is called the attunement theory. Now, attunement theory is not one theory. Attunement theory primarily takes the baseline as that there is some sort of a tuning in, or let us say readjustment, realignment of that perceptual capability based on the ambient language that that children are exposed to. So, there are primarily two premises on the basis of which attunement theories are talked about. The first one is that infants begin life with the ability for categorical perception. That ability is already there, they know how to segment sounds, how to differentiate between different sounds. Now, this is an ability to partition sounds into categories. However, in a important departure from the previous theories, this capacity from attunement theory perspective is just a basic level cut, in the sense that you do not really have the capacity to create phonemic distinctions at that level, but it is a basic level cut where you are able to partition sounds on certain based on certain features, but that does not necessarily translate into being able to distinguish sounds in all languages of the world. That is the main point of departure. So, this is not the same as being able to segment all sounds of all languages. There is an innate ability to distinguish between sounds or among sounds, but this is a very basic level as they call it, a basic level cut. So, it is a very basic level kind of an understanding. The second premise is that the experience with language tunes those basic perceptual abilities. If you remember, we have also talked about those perceptual abilities being present to some extent, at least in some other animals as well. So, the experiential domain, the ambient language, fine tunes that for humans. So, experience means the fact that different sounds lead to different meanings in words. So, the same sound appearing in different cases, and if you just change it with a different sound, the words will change their meaning. So, that kind of an understanding the child develops as he grows through life in the first year of his life. So, this is not the same as maintenance or loss mentioned earlier. So, as we go we have to constantly remind ourselves of the previous theory. In the previous theory, they said that the ability is kind of fully developed. Developed in the sense that infants can distinguish between sounds of the language. Now, sounds of the language primarily means the phonemes of a language. So, the difference here is that they are not able to distinguish between phonemes as such at that early age, but they are able to make some judgment on the basis of the sound system. That understanding of phonemes develops a little later, and that development is dependent upon the child's exposure to language, more and more of linguistic cues. So, this and then as a result what happens is that some sort of a perceptual reorganization happens. Okay, so, this includes tuning, modification and reorganization of the perceptual abilities by exposure to a particular language. So, depending on the language they are exposed to, that tuning in will happen. That is the second premise. Now, based on these primary two premises, there are three important theories within this larger domain. Perceptual assimilation model, which is better known as PAM, then comes the PIMIR model by Walker, and then Kuhl's native language magnet theory. We will go through one by one each of them, but each of them are very important theories. So, we will just give a brief overview for paucity of time, but you can always look up the references. So, perceptual assimilation model, the primary starting point is that they agree that speech perception is shaped by perceptual attunement. So, you have there is some sort of an attunement that happens at a perceptual level based on the ambient language. So, the phonological contrast that the infant learns is due to the ambient language environment. Phonological contrast, for example, in Indian languages pa and pa are contrasted, phonological contrast, meaning they are two different phonemes in Indian languages. Most Indian languages, these are two independent phonemes, but in English language these same two sounds are not two different phonemes. So, in English, when the alphabet P in English, which typically has the sound pa in the word medial or final position, if it comes in the initial position, the sound that you will hear is some sort of closer to pa in Indian languages. So, that is the contrast we are talking about. So, in the which two sounds create a phonological contrast is dependent on the language that you are living with. So, in case of first language, the native speakers first get sensitive to the important single feature phonetic difference that signals the phonological distinction. What does single feature phonetic difference mean? Given the same example pa and pa, in our case in Indian languages we have something called aspiration, and also we have voicing. So, pa and pa differs in terms of aspiration, pa and ba differs in terms of voicing. That is why we have like pa, pha, ba, bha. So, you just permute and combine the voicing and the aspiration, thereby you get four-way contrast. This is not the same way as in English, for example. So, this is the single feature phonetic differentiation. So, pa and pa differs on one feature, similarly pa and ba differs on one feature, and so on and so forth, like that. So, They also learn those phonetic differences within category that do not lead to phonological distinction. For example, again going back to our previous experiment where we saw that artificially created 6 different sounds that were different in terms of the VOT. Infants could distinguish between exactly where pa stops, pa turns to ba. But within the entire inventory of all the different VOTs that create pa, they did not really show interest. So, that is what we mean by within category phonetic differentiation. So, within that larger category of pa, there were different VOTs that they heard. So, that means the infants are able to distinguish between that phonetic difference that creates 2 phonemes as well as ignore those differences that do not create a phoneme. So, this is what assimilation means. So, the features responding to one particular phoneme gets assimilated into one category and then thereby you differentiate it from the neighboring category, like that it happens. So, they learn to attend to the relevant variation as well as ignore the irrelevant variation, that is in case of the native language. Now, in case of a non-native language, if the phonological contrast is perceptually assimilated as similar to the native language, then it should be easily discriminated. So, that is how PAM tries to explain the ability of some infants that who could distinguish between sounds, difference of sounds in different languages, even if it is not their L1. So, the reason here what they are saying is what this theory talks about is that the perceptual assimilation of features into one category, one phoneme versus another category in terms of another phoneme, if that matches the non-native languages differentiation, then the child will be able to distinguish even non-native languages. So, plainly spoken, if the phoneme inventory of 2 languages are similar in some sense, then the child there is a higher likelihood of the child being able to distinguish those phonemes in a language that is not its own language, own native language. So, conversely, if the contrasting non-native phonemes do not assimilate to the native contrast, then they will be finding it difficult to distinguish. As I just said that pa pha difference in case of Indian languages versus English. So, in Indian languages, the features that distinguish between pa and pha do not assimilate to the same contrast in English language, as a result of which the infants might find it more difficult to distinguish English phonemes as opposed to the native language phonemes. That is the idea. So, how do the features get together and create the contrast between phoneme 1 and phoneme 2? If they match the L2, then the child will be able to easily discriminate. That is the fundamental idea. So, as a result, this theory predicts that performance on non-native contrasts will vary from poor to excellent depending on the contrasting non-native phonemes. So, basically how the match can be, it is not a this or that kind of a thing, it is a graded difference, as the theory describes that you can have a 1-to-1 mapping. So, both features, so 2-way contrast can happen. So, pa pha in Bangla and pa pha in Hindi, let us say. So, it is easy. But sometimes what might happen is that the pa pha distinction in Indian language versus the only phoneme which is pa. So, the matching between native and non-native phoneme contrast can happen at various levels, as a result of which the performance of the child can go from poor to good to excellent. Okay. So, that is about in short what is PAM, the perceptual assimilation model. The another important theory within the attunement theory group is the native language magnet theory, which was proposed by Kuhl. Now, the idea here is that infants start their life with ability to partition sounds roughly into categories. That is the same that pervades all throughout these three different theoretical positions. So, language experience, however, is necessary to fine tune this ability in order to perceive sounds of their own language. Now, the main focus of this theory is the process through which this tuning process happens. till here it is the same thing, that the perceptual abilities are similar, then you fine tune the ability based on the ambient language. But how does it happen? This theory has a very interesting take on that. So, she proposes that exposure to language changes the wiring of the neural pathways. So, there is a neural underpinning as to how we finally learn to distinguish between the sounds. So, through experience the neural pathway become committed to one particular configuration. This way it creates some sort of a sound map. She calls it a sound map of sorts. So, in our in our brain, in the neural architecture, there is a sound map where various different slightly differing sounding phoneme will be grouped together. So, it creates a map which is not a point, but a map. That is why this name is very significant, where it can take care of the within category differences. Okay. So, ultimately language learning produces a dedicated neural network that code the patterns of native language speech. So, as the child grows up hearing different kinds of manifestation of the same sound, it all goes into the gets coded in the brain, that there is a dedicated neural pathway to understand that, to process that. Over a period of time it creates a prototype of that particular sound. Okay. So, the one consequence of this neural commitment is what they call perceptual magnet effect. So, brain stores representations of highly frequent sounds as prototypes, and this acts as a magnet for other members of the same sound category. So, going back to our power for distinctions, an Indian child will hear various kinds of manifestation of the pa sound in different kinds of environment, word environment. So, the pa sound will be appearing in different positions, word initial, medial and final positions, as a result of which the various small distinctions between those sounds will be all clubbed together, and there will be a prototypical representation in the brain that will be the pa sound for Hindi speaking child, for example. As a result, phonemes that are similar to the prototype are made to sound similar, because they have all been clubbed together and some sort of a satellite around the prototype. This decreases the ability to tell the difference between members of the same phoneme category. That is why, now this again we go back to our that VOT experiment. This is why it was difficult, it was not possible for the child to distinguish between the minute VOT differences within the same category of sound pa, because they do not recognize it, the brain does not recognize it, because they have all been clubbed together in the same sound map. Okay. So, all variants of that phoneme therefore sounds the same to us in spite of possible differences owing to the different factors like VOT and so on. Now, this process makes us less sensitive to the within category difference, also between category differences of other languages, because what is between category difference in other language may not be a between category difference for us. So, similarly, this works both ways. Now, this has also been claimed that this perceptual magnet effect may be human or human language specific, it may not be part of the all purpose general broad perceptual abilities, it is a separate kind of an ability. Now, this also this theory also provides explanation as to how this tuning in happens. So, tuning in happens at the level, at the neural level, but how does it happen? How do the connection between the neural and the auditory apparatus work? This is how they have proposed it. So, each time we hear phonemes like ra and la, now ra and la belong to the same spectrum. Ra on one hand, let us say, and the other end the la sound. So, this is a spectrum. Now, depending on the language in which you are, in which the child is growing up, they will hear different parts of that segment being produced. For example, in both Japanese and English infants, they are likely to hear a range of different sounds within that spectrum. Some more like la, some more like ra, and some in the middle. What does this mean? Is that there is a very famous experiment carried out on a different sound spectrum ba, da, but let us just see an example here. So, let us say this is a spectrum. Here you have the ra sound and on this end you have the la sound. Now, during the infant's exposure to the speech sounds in the environment, it is not necessary that the child will hear the ra always at this point. sometimes it can be here, sometimes here like this. Somewhere in the middle the distinction will be blurred. And again on the other hand, when you hear the l sound, it could be here, it could be here, it could be here like this. So, this is what we mean by in the spectrum the children, the infants will be exposed to different kinds of different sounds within that spectrum. Now, depending on what you are, which of those manifestations you are exposed to more is how your differentiations will be finally building up. So, there are different distributional properties. This is what we meant by distributional property in the speech signal of different languages, and these properties help different prototypes to develop. Right. So, Japanese and English infants will hear different distribution of the pattern. Thus, English infants develop two prototypes at separate points of the spectrum, while Japanese develop an intermediate one. So, to go back here, the Japanese, it is highly likely that the Japanese hear more sounds in this part of the spectrum. However, the English children will hear their auditory signals will peak here and there. So, this could be a range here, another range here, but very less in the middle. For the Japanese kids, the most of the iterations of that sound will be somewhere in the middle, and that is what will decide whether they hear it as two sounds or whether they hear it as one sound. So, this is the idea of the entire theory. So, this was checked by another very famous study by May et al. 2002. So, they had 6 and 8 months old infants. They were made to hear 8 artificial syllables varying along the tada continuum by changing the distribution. Half the infants heard these syllables in bimodal distribution. Again bimodal, by bimodal we mean, so let us say this is our ta here and we have our da here, right. Now, half the children heard the bimodal means that they heard a lot of distinction here and a lot of sounds here, and other half near the ends of the continuum. So, this is the continuum and this is the ends of the continuum. So, they half the children heard a lot of sounds here and quite a few here. So, these are the two ends of the continuum, and other half they heard more of the sounds that were in somewhere in the middle. So, they were in the middle of the continuum. So, this is neither the extreme ta, neither not the extreme da sound. In the test phase, they either heard the alternating sound ta da like this, or they heard the non-altering only the da or ta sound. Very simple example. So, half children, very young infants, they were made to hear sound on the spectrum. Half the children heard it in the two the bimodal distinction, bimodal as in two modes in the within the same spectrum, but two modal, two endpoints, and the other half heard only those sounds that were somewhere in the middle of the spectrum. Hence, they were exposed to only one kind of a bundle sort of a sound, and in the test phase they were hearing either the same sounds or alternating sounds. So, what they found out was infants from the bimodal group listened for longer to the non-altering trials. So, those infants who heard the ta and the both, they were looking longer, they were listening longer to the unimodal. So, the non-altering only ta or ba kind of thing, sorry. So, that means they have figured out the distinction that this is not the same as the one that they heard before, and then the alternating ones. So, this meant they could distinguish between the groups, the group before and the group now. The unimodal group on the other hand did not show any difference in behavior, indicating they treated both varieties of sounds as similar, because they heard those sounds which were in the middle of the spectrum. So, they knew only one. So, whenever they heard, whichever they heard, they would consider them as the same sound. So, thus simply by varying the frequency of input of the different variants of the syllables, they could create different category boundaries of sounds among the test subjects. Thus, they concluded that infants are able to use distributional information in input speech to detect phonetic category structure. So, how do you create your phonetic category? How do you create those boundaries depends on the spectrum that you are given, that the infant is given. If it is a bimodal kind of an input or it is an unimodal kind of an input, that will decide what kind of category boundaries they will create. However, like all theories, this has also been criticized. One of the most important ones is this particular study carried out in 2001. They believe that the infant's abilities of distinguishing sounds have been overestimated. They do not really have that kind of a fine-tuned sensitivity to the boundaries. So, they had 6 to 14-month-old infants and 2 to 3-year-old children, and they had 3 different kinds of contrast that were created into the stimuli. And the task was to distinguish between these 3 types of contrast. So, they had vowel contrast. So, the a, distinction, the VOT contrast on the basis of which the sound will change from ta to da, and then the fricative contrast, the sa, sha distinction. So, there were 3-way distinctions and they tested on 2 groups of children, infants and young children, 2 to 3-year-old children. What they found out was only 65% infants could pass the vowel distinction, which is not that impressive. Only 65% could distinguish between the vowel, that is the between a and u distinction. 35% VOT contrast, which is quite low. So, the VOT contrast is our ta da contrast. Only 35% of infants could. Among children, only 56% passed the vowel contrast. So, basically the result is not that impressive. Had they been able to judge and create the boundaries easily, this would not happen, because here the 6 to 14-month infant, they are not very small children, 14 month is more than 1 year, and they also did not do very well. So, as a result of which she said that data do not support that infants have clearly defined phonetic boundary. And the reason, she finally said that the reason why the earlier findings could be provided, the previous researchers provided the earlier findings, because they probably did not include the data that was that had fuzziness. Fuzziness in case of infant data basically refers to all those things where the children had lack of attention, they were crying, they were fidgeting or whatever. So, they have simply basically she wanted to say that the data has been cleaned only to keep those data points that showed the distinction. So, as a result of which she did not quite agree with the previous findings. Another study similarly in 2003, they pointed out that this kind of experimental studies, that infants are given repeated iterations of the same kind of contrast like ta, da, pa, ba sort of thing. So, but this is not how real life really works. So, laboratory findings may not really be a good indicator how real life sound processing, sound perception happens in case of infants. That is the idea. So, normal speech, in normal speech these sounds appear in variation, because of the the variation. By variation we mean allophonic variation, for example, depending on the environment in the word, morphosyntactic structures and so on and so forth, the sounds will vary, the same sounds will vary. So, depending on the speaker and also on and so forth. So, the success of lab studies do not presuppose real life success. So, that is the other criticism of this. However, many like all theories, we have some group of evidence in favor and another group of evidence against the findings. So, on the basis of this, they have said that there is no need to propose innate knowledge at all. That is what Perenberg said. Rather, infants could be building up their knowledge bottom up through experience. As May said, that there is the experience has more role rather than the innate ability to distinguish. As they grow up through the entire first year of life, the experience probably helps them fine tune their abilities. So, this is some work is still going on in this domain. Now, we will move on to the third theoretical position by Walker and her group. So, where they propose a developmental framework for processing rich information from multidimensional interactive representation. Now, this theory also talks about the attunement. However, in this case they have taken into account not just the phonetic properties, that the acoustics of the sound, but also a lot of other information which creates a very rich environment for the child to grow up in. So, this is not just one plane, one dimensional kind of a development, but a multidimensional development, and basis of that multidimensional input, there are different planes in the mind of the child, that on which they on the basis of which they eventually are able to create the phonological inventory, and which in turn helps them to learn language. So, let us go one by one. So, in order to account for contradictory findings regarding infants speech perception and its relation to later language acquisition, they came up with this theory. The main idea is that infant receives a rich set of information in speech input, and this input is organized along multidimensional interactive planes. So, it is not only multidirectional, but also it is interactive. So, those planes interact with each other. So, at first the first important thing is that processing of speech input happens at two levels, phonetic and indexical. So, phonetic we have already seen the properties, phonetic properties of for example, acoustic features or articulatory features, those are part of the phonetic level of input. So, when you hear a sound, there is this phonetic input, the sound, the VOT, the other acoustic properties and so on. Indexical on the other hand, it is also sometimes called paralinguistic. It is very difficult to distinguish, I mean to parse them separately between indexical and phonetic. Sometimes they actually have a lot of interaction, but still for the purpose of description, for the purpose of explanation, let us look at how they have put it. So, indexical properties are basically paralinguistic features like properties in the speech input that carry information about other things like gender, like the affect, then you have speaker identity, age, emphasis and so on and so forth. So, for example, pitch could be one acoustic feature, but pitch also has a lot of interaction with the affect. So, when you want to be, when you are somebody is angry, their pitch might go up, or various other things. So, speaker identity, so pitch could be higher for female speakers as opposed to the male speakers and so on and so forth. So, these are interconnected features, but there are these two features in the speech input that is there. Now, grouping of information on the basis of similarity, then co-occurrence and other statistical regularities are the tools that the infant uses on the incoming speech input. So, the infant is not just absorbing everything that happens as it is, but they actually apply some sort of a statistical mechanism to figure out based on the co-occurrence, how many times these two sounds co-occur, how many, what is the pattern of occurrence, and various kinds of what are the similarities across boundaries, word boundaries or whatever. So, these are the things that the mind also applies, on the basis of which we finally create, we finally group those input in multi-dimensional plane. So, there are three primary plane that the theory talks about: the general perceptual plane, word form plane, and then the emerging phonemic plane. So, first and foremost the perceptual plane, where you have the processing of phonetic and the indexical information, and that feeds into the word form plane, where some sort of a word, sort of a category without the meaning part is created, which in turn creates the phonemic boundary. So, understanding of the phonemes of a language actually goes through this kind of a structured multi-layered interactive format. That is what the theory talks about. So, this is how I have put it for you to understand easily. So, the general perceptual plane, this is where there is this coming together of the phonetic and the indexical properties, that is the general perceptual. So, at the very basic level, that is what you are creating. This is where they are coming together, and this feeds into language specific categories. So, this is what we were talking about before as well. So, by language specific categories in terms of the sounds, and then that will feed into the word form plane, which is word form is not the same as words. When we say words, we mean a kind of a category which also has meaning attached to it. So, form and meaning together comes in the word, but here we are just talking about word form, kind of a structure that is created. This is what the theory calls it, extracted sequences that form cohesive units, some sort of a coming together of of certain sounds that typically co-occur, something of that sort. And then once the infant has established a sufficient number and density of meaningful words, then generalization of commonality occurs. Once you have got an adequate amount of those forms into place, then only you will be having adequate data to have a contrastive analysis of some sort. Thereby, you will be able to. So, for example, it is only after the child has heard enough instances of pul and phal in different times, in different contexts, that they will be able to. So, these are word form at that point, that they do not yet know the meanings, but these are word forms, word plane, and that is when they will realize that because they occur in different conditions, they seem to mean different things. So, these are two phonemes. So, pa and pha are different phonemes. So, the phonemic plane occurs at the end. So, after the word plane, then we have the phonemic plane. Right, that is how the, of course, there are other planes after this, but we will not go there, we will just take to the basics. So, let us look at the general plane, let us explain it a little bit. So, information in this level is in the speech environment, this is what we are getting from the ambient language. Right. So, various distribution on phonetic or indexical properties will be clustered together to form categories. So, for example, different realization of the pa sound in terms of position. So, initial, medial and final position, and then similarly indexical categories like gender. Gender can have two different manifestations, the face. So, the identity, facial identity as well as the voice information. So, the infant's mind takes all of this information and starts to process in terms of the general perceptual level to create the boundaries, right. So, create the clusters of some sort. So, the pa not only appearing in different positions in the speech, but also uttered by different kinds of people, different kinds of carrying different kinds of indexical information. Sometimes the environment may contribute simultaneously to the both phonetic and indexical clustering. For example, pitch information is used for voice recognition, voicing distinction as well as vowel color. So, pitch may also contribute to word meaning, vowel color may contribute to affective valence and so on and so forth. So, that is what we mean by a lot of interaction. That is what the one of the fundamental aspect of this theory also is. There are three different planes, and within each plane as well as across planes there is a lot of interaction. So, at the general perceptual plane there is a lot of interaction between the phonetic and the indexical categories as we have just seen. Then the word form plane is created. The word form plane in this consists of extracted units without meaning attached. This is just unit, certain sounds coming together in a cluster and they appearing significant number of times in order to be represented in the mind as a single unit. So, those kind of clusters are created. This is an exemplar based category. So, it is not exactly a word based, but an exemplar based, meaning a kind of an example of this kind of a cluster. That is how the feature extraction happens. So, overlapping exemplar based on phonetic and indexical properties are clustered together. In the next level, the infants need to map word forms on concept. This is the most difficult part. So, first they have created the clusters in their mind because of repeated number of times that they have heard it, and then eventually they have to map that cluster on a concept. So, a pan refers to this object, a fan refers to that object, that kind of mapping has to happen. In a naturalistic word learning situation, the child will be exposed to the word in different contexts spoken by different people, and we will also see different instances of the object category again in different contexts. So, the object also they will see. Now, depending on the overlaps that this will create, the child will find it easy or difficult to learn the word concept. So, sometimes they will hear the word and they will see the object in their in their vicinity. If that happens enough number of times, then the mapping will be complete, and then eventually they will learn that this is the word that denotes this particular object, like that. This is what. So, depending on the variance in the occurrence of these things, two things together, it will be either easy or it will be difficult for the child to master, but eventually they do master this. So, that is when the meaning part gets attached to this word plane structure, the extraction that happens at the word plane. Finally, we have the phonemic plane. So, in the phonemic plane, this is the case where the vocabulary as expands and more words with overlapping features are added. So, as the child grows, this is this comes at a later stage, right. So, higher order regularities emerge from the multidimensional clusters. They have had enough vocabulary by that time, they have heard enough, they have seen a lot of objects that are denoted by those things. So, the understanding of the phonemic boundary gets more and more clear at that level. Only when they have this, there is this concept of minimal pair. So, this is what we mean here. They do not talk about minimal pair as such, but this is an easy concept to understand with to help this out. So, they have minimal pair, matlab they have the two words, also they know that these two words mean two different things, as a result of which they can arrive at. So, pan and fan differ only on one sound, that is the pa versus fa distinction. So, pa and fa are two different phonemes in this language, because just by changing one I can have a different meaning. That is the understanding of the phonemic level, and that can happen only when the child has been exposed to adequate number of words in different kinds of conditions. So, these higher order regularities gradually coalesce into a system of contrasting phonemes, and so once a critical mass of word from meaning linkage is established, we arrive at the phonemic concept formation. So, as the lexicon grows, phonemes get more and more firmly established. Now, this model as a result describes the interactive representational planes together working to help the infant process incoming speech input. Not only these, there are these multiple layers of planes in the conceptual level through which the child finally arrives at the phonemes, but there are also other kinds of dynamic filters through which this works. This is the beauty of this particular framework, this particular theory. Now, there are those interactive planes which also works through interactive dynamic filters, as they call it. So, one of them is initial bias, then task demands, and of course, developmental level. So, developmental level at which the infant is will be interacting differently with those different multi-dimensional planes as opposed to another child at a different developmental level. That is what we mean. But it all starts with initial biases. Initial bias gets things started. So, and then if you have a particular bias, then you will be learning your learning will go in one trajectory, so to say. So, this is how this entire system kind of gets started. So, on the one hand you have multidimensional interactive planes, on the other hand you have these dynamic filters, all of them interact with each other to give the child the specific kind of speech perception capacity that ultimately they will be growing into. Ultimately, that will be the building block for them to learn language. Language acquisition will happen based on this. So, a coordination among all of these eventually helps in language acquisition. So, that is with that I hope I have given you a brief overview about the attunement theory, how different there are three different kinds of theories, all of which are clubbed together under attunement theory. Each of them has contributed significantly towards our understanding how infants might be able to arrive at the speech perception and fine tuning which they can arrive at the word level understanding. So, starting whether you are going by the PAM theory or going by the the other the PRIMIR theory, primate theory, or whether you are going by the magnet theory, either all of them have contributed to some extent, and they all have adequate literature exists supporting all of them. There are of course criticisms, but in their own turn they all are very significant contributions in this domain of speech perception in infants. So, here we stop with the lecture 3, lecture 4 we will take it forward and we will see other kinds of speech segmentation, how it works and how they eventually figure out how words really work out. Thank you.